An esterification reaction is a reaction in which we form a new functional group, which is called an ester. And esterification reactions are another type of condensation reaction because water is going to be formed as a byproduct, but they're a bit different than the elimination condensation reaction that we saw earlier. So we know that water is going to be a product here. Water is going to be a byproduct. And the other product is going to be this functional group called an ester. So this is what an ester looks like. It's got a carbon which is double bonded to an oxygen, like we saw before in a carboxylic acid. But now, instead of this oxygen being part of a hydroxyl, it's single bonded to another carbon, and maybe there's some more molecule over here. Esters are really useful functional groups because they can act as linkages between molecules, and they can be used for making polymers, which are big, long chains of atoms, big, long string molecules that can be used as building blocks for cells or for molecules or for synthetic things like fabrics. So we always need to start with a carboxylic acid and an alcohol. We're going to get an ester, and we're going to get water as a byproduct as well. In order for an esterification reaction to happen, we need a catalyst, which is typically a concentrated acid, and we need a little bit of heat in order to get the reaction going as well. And just notice we're going to turn this carboxylic acid. So this is a carboxyl group, and we're going to turn it into an ester, right? And they're similar, but they're not the same. We would have some other rest of the molecule over here instead of a hydrogen, whereas the carboxyl is only connected to carbons on one side of the molecule. So let's take a look at an example, and we'll see how to name it using this example as well. Starting materials for an esterification reaction are always going to be an alcohol and a carboxylic acid. And what's going to happen is the oxygen that's part of the alcohol is going to come and it's going to attack this carbon from the backside, or it's really the electrons here that are attacking the carbon from the backside. And we're going to form a new bond between this oxygen and this carbon over here. When that happens, this oxygen is going to get kicked off in order to make room for this new bond that's being formed right here. And this hydrogen that was part of the hydroxyl gets kicked off as well. So we form a new bond between the oxygen and the carbon here. This is now my ester functional group. And these guys that got kicked off, we have a hydroxyl and a hydrogen. As you might guess, they're going to want to bond together to make water, which is going to form a byproduct. So then here I have my product. It gets named with the part that came from the alcohol as a branch, and the part that came from the carboxylic acid gets named as the parent chain. So this guy started out as methanol, so it'll be a methyl, and then this guy started out as ethanoic acid, so it'll be ethanoate. So the full name of this ester will be methyl ethanoate, and water will be the byproduct. On paper then, we have our methanol, this is our alcohol. We have the ethanoic acid, which is our carboxylic acid. When they react together, the hydroxyl that's part of the acid and the hydrogen that's part of the methanol, those guys are going to leave and they're going to form water. And then my oxygen here that's part of my alcohol is going to end up bonded to the carbon that was part of the carboxyl group. And then that's going to make my new ester group. So let's put the ester together first, and then we'll look at the byproduct. So I'm going to keep my colors the same. Draw in purple here the things that came from the alcohol. So here's the carbon with its hydrogens, and this oxygen came from the alcohol too. Now the oxygen, though, is now bonded to this carbon. It's part of the ethanoic acid. And it's brought with it the other stuff that it was bonded with. Then my second product is water. The water has got an oxygen and a hydrogen that came from the carboxylic acid, and it also has a hydrogen that came from the alcohol. Then when we name the ester, it's got a two-part name. Half of the name comes from the alcohol name, and that gets named as a branch. So this is going to come in front of the name. And then the ending of the name is going to come from the carboxylic acid, but we're going to change the oic acid to O8. So I'll keep my colors the same again to make it clear. So the part that came from the alcohol is the methanol. So that will be named as methyl. And then I do have a space here, which is uncommon for organic names so far. This part here, it came from an ethanoic acid, so it's going to get changed to ethanoate. So the name of this ester then is methyl ethanoate.